So Dingo is a neutron radiography and tomography instrument. So it actually uses subatomic particles that are produced from the nuclear reactor, which is just here. And it uses neutrons, which are highly penetrating. They pass through samples like these drill cores and create shadows on this detector here, just like when you go to a doctor and get an X-ray, except we're using neutrons particles instead of light X-rays. And as these samples rotate, we collect thousands of radiographs, and Dingo and the instrument scientists, we turn that into a three-dimensional representation of our samples. So Dingo is an excellent instrument, but the issue with our setup was that we could only scan samples up to about 35 centimeters in height. So in order to accommodate large samples, we need to really modify every single component of the instrument, starting with the sample stage. So normally this is designed to rotate samples like this, and small samples. So in order to accommodate very large samples and the height of this, we had to remove any excess motors from here. It increased our range and height that we could move in that direction, and also towards the detector and towards the reactor. We had to make modifications to our camera system, our detecting mirrors. Basically, every single component of the instrument itself needed rewiring as well. So just over on this other side, all the electronics to operate the drill rig need to be installed as well. So it was about a 6-month project to get all the components installed.
Okay, yeah, so this rig we started designing it last year, so there's a lot of work that's gone into the design and the structure of how we're going to achieve the dimensions of what's required by the scientists. So we have these rock core samples that come from the university. So that a lot of them are odd different shapes. So we had to come up with an idea of how we're going to encapsulate them in a canister and rotate them around at a certain speed as required for the camera on Dingo. So as you can see, there's a lot of design work's going into it. It's quite a large rig for this instrument, and we've come up with this canisters idea. So it's a team effort. There's electrical engineers involved and draftsmen and draft people involved in this job. And so we've come up with this canister to hold these rock core samples, and they're a standard sort of length. So we had to come over about a metre length to fit them into this. So we've come up with 4 canisters, and we're able to do look at 2 canisters at the same time now with a field of view.
Yeah, so the mining industry keep their drill cores in trays, and they have a standard geometry. So the geometry of our prototype is designed to match those trays. So we treat these like cartridges. So basically, in order to keep track of the industry cores, we take whatever is in that tray, transfer it directly into our setup. It goes through the rapid scan process. At the end of that, we manually interchange them. I should point out this is a prototype. So the idea is this is designed like a cartridge. So if the high throughput scanning is adopted by industry, the idea is that we can develop a robotic interchange system so we can really push high throughput so that our staff don't need to be here on site overnight during scan processes.